Yeah, so one well this okay, so like we said, this is G3 plus G4 plus what G5. Okay. Well, we needed to find G3. I think we had three for G3. G3 was three. And then G4 was seven. And then G5, okay, which we were calculating was 25 minus what 15 plus 3. So that will be 10 plus 3, which is what 13. Okay, so this will give us, we have 3 plus 7 plus 13, okay, which gives us what? Which gives us 23, okay, for the summation. Then let's take an example of the product. For the product, this will just be G1 times what? G2, which we already calculated. G1 was 1 and then G2 was also what? 1. So when you multiply, you get what? 1. Okay. So that is how you find the summation and the product of the terms of a sequence. Okay, let's move on. If there are any questions, you can ask, else we are moving on. Okay. Now we also have what we refer to as strings. Okay, so when we talk about strings, we are talking about uh, elements. Okay, it says a string over X is a finite sequence of elements from what? X. Okay, good. And then for an example, we have this string here, or we have this sequence Q1 is B, Q2 is A, Q3 is A, Q4 is what? C. Okay, and then once we combine these sequences, we get a word. Or what you call as a string, okay, which is B A what? C. Okay, so B A C. Okay, and these things come into programming a lot. Just now, let's move down a bit. Yeah, so we have once again operation on strings. Okay, so if we got elements like this, okay, we could determine the length of the string, and the length of the string depends on the manner in which the terms have been arranged, and then the definition of each word term. So when you come down here, we have, for example, alpha is been defined as what? As a string A B A. Okay, so alpha is A B A, and then beta is what? A cube, B raised to the power 4, B raised to the power 32. Okay, so I may ask you to write what? Uh, okay, for now we are looking at the length of the string. So if I ask you to find the length of the string, okay, that's in this case, this is what 1, 2, 3, 4, 5. So we got the length to be 5. Then in this case, we have 3 plus 4 plus 32. Okay, which will be 3 plus 4 is 7 plus 32 gives us 39. Okay, so that will give us the length of the string. Okay, let's go down and then see the next. Yeah. Okay, so this is what I was talking about earlier. Okay, so we can combine strings. T has been defined as AAB. E has been defined as CABD. Then if I write TE, okay, T is just a concatenation of the two strings. Okay, so it's here, concatenation of alpha and beta. Okay, so when I write TE, I'm concatenating it in the form with which TE has been defined. So TE just means AAB, which is T, okay, and then E is what CABD, okay. The same way if I write ET, then ET is going to be what CABD and then AAB, okay. So that is the concatenation of what of a string, which we are very much aware of. So this topic looks quite simple, okay, straightforward. These are things that we've seen over and over. And your material, there is a reference link, okay, for you to watch more sequences and strings. So you can go to the reference link on the page, and once you click on it, it will take you to the information you need. The next thing we want to look at for today will be the concept of matrices. I'm going to share my screen on that. Yeah. Okay. So matrices, we want to understand the concept of a matrix, what a matrix is, okay, and then use matrix to model the relationship between what two sets, okay. That is the outcomes for this very material. Now, when we talk about a matrix is a rectangular array of numbers, okay, and it always have m rows with what n columns, okay. We call that an m by what n matrix, okay. Good. Now it says a matrix with the same number of rows is called columns is called what a square matrix. We'll touch on an example very soon. So this is an array of numbers with rows and columns, okay. So this a matrix is, we have the rows this way, so these are rows, okay. And then this will be what the columns of the matrix. Good. So this forms the rows of the matrix, and then this forms what the columns of the matrix. Okay, so we have rows and what column. So in this case, we have 3 rows here. 1, 2, 3, and then we have what 2 columns. So 1, 2. Okay, good. So let me write it this way. This will be the element here is what 1, 0, 1, 1, 2, 3. Now, in relation to the sequences we just looked at, this is 1, right? This is row 2, this is row 3. And then this is column 1, this is column 2. So if I want to refer to the element in the first row, first column, Okay, I'm going to refer to it as this. This is how I write it. A1, 1. Okay, row 1, column 1. If I want to refer to the next item, it will be what? A1, 2. So row 1, column 2. Okay, the values are 1 and 1 respectively. Then the next item will be what? A2, 1, which is what? 0. And then similarly, we also have A2, 2, which is equals to what? Which is equals to 2. A3, 1 is 1. And then finally, A3, 2 will be equal to what? Will be equal to 3. Yeah. So this is how you make reference to the elements in a matrix. Okay. So matrices, like we said, we can use it. It's just like a cell, a spreadsheet. Okay. So any spreadsheet we have like in your Excel. Okay. Yeah. This figures we are having here, these numbers we are having here are cells. Okay. They are cells. So that is what we are referring to as what? A11. Just like we read the Excel sheet as A1, B2, B3. Similarly here, elements are read as rows and what? And columns. Okay. And they represent cells. Which means that they have a wide, matrices have a wide range of what? Application. Okay. Now let's proceed. Yeah, so we are saying that the general form of a matrix is written like you see here. So matrix A is what? A11, A12, all the way to A1n. And then when you move along the rows, we are going to get A11, A21, all the way to what? AM1. Okay, good. Now, equal matrices are matrices which have what? The same number of rows and the same number of columns with corresponding entities in every position are equal. Okay. Yeah. So in other words, for you to have an equal matrix, then they should have the same size and have the same what? Corresponding entities in the matrix. Good. Now the next thing we want to look at are operations of matrices. For example, the matrix addition and then matrix uh, multiplication. Okay, good. So when it comes to addition of matrices, we add element in the same what? Row and the same column. Okay, so for example, you can only add an element in row 1, column 1 to the element in row 1, column 1. Okay, so when you are doing addition, you pick row 1, column 1, row 1, column 1 for the next matrix, and then you add. So this will be 1 plus what? 1 plus 3, okay, which equals to what? 4. The same way when you add in, this is row 1, column 2. So you come and pick row 1, column 2 to add. That will give us 0 plus 4, which is equals to 4. Row 1, column 3, row 1, column 3. When you add, you're going to get negative 2, which also tells us that before you can add matrices, then they should have the same what? They should have the same size. Okay, they should have the same size. So if A is matrix 3 by 3, then the matrix B should also have the size what 3 by what 3. If the matrix A happens to be let's say 4 by 2, 4 rows, 2 columns, then B should also be 4 rows, 2 columns, because like we said, we can only add corresponding what elements together. Okay, good. So you cannot have A to be of a different matrix size than B. They all have to be what the same, because we'll be adding. When you come here, row 2 column 1 plus row 2 column 2 give you 3. Row 2 column 2 plus row 2 column 2 here will give you -1. Row 2 column 3 plus row 2 column 3 here will give you -3. Row 3 column 1 plus row 3 column 1 will give you 2. Row 3 column 2 plus row 3 column 1 will give us what? Will give us 5. And then we also have what? Row 3 column 3 plus what? Row 3 column 3, which will give you 0 plus 2, which equals to what? 2. Okay, good. Any questions so far? Class, any questions so far? Okay.
And I'm okay with it.
Okay, fine. Let's continue.